Hello, everybody. Today's second day of week 5. We're, I guess, well past the halfway point now. Um, I submitted midterm grades, but those don't really impact anything. They don't show up on your transcript or the only thing I've ever seen happen with midterm grades is if you have a whole bunch of really bad midterm grades, academic advisors will reach out, but they're often very, very busy and may not have time to reach out to everybody. But uh, I submitted those. I just opened up the grade book and turned in what it said late last night. So whatever was in the grade book last night, um, the probability quiz, there was a little glitch a couple people encountered. I'm not sure what happened. I think it's fixed now. But on one of the questions, there was like
11 answers.
Yeah. All of the multiple choice questions should have had 4 answers. So when there's like 8 answers to choose from and 10 more blank answers, and Canvas said that the correct answer was one of the blank ones. Yeah, I'll regrade that. I'll go back over the quizzes. So if it's something that seems like a glitch in the software, I'll definitely go back over that. That is out there. If anybody does really badly on those quizzes, right? Math, there's not any math classes that are prerequisite for this, so we just had very brief coverage of it in class. If you need me to open up a quiz back up, just let me know. I can open that up for a second pass or something if you would like to improve the score. Um, Otherwise, yeah, all of the content things on those major learning objectives were in the first half of the class. So the rest of the class, we're just going to be making games, talking about problem solving and getting to things. So mostly what we're going to need today is just to sort of follow along the example using Godot. We'll put together a quick 3D world. We're going to start with that. And then next week we'll do a 2D thing, probably an overhead map. Goes with the next assignment. The next one's similar. You'll choose four of the screens from the original Legend of Zelda, A Link to a Map, and then duplicate that map with your own storyline and art. Artwork doesn't have to be good, but it's game development. So you're looking for your own artwork. It does not have to be good, and your own storyline, and just duplicate what's on that map, the movement and stuff. Have a goal to work towards. Whenever we do our own thing completely from scratch, it's too easy to just change the design and skip parts. So it's important to replicate other games from time to time. So that's what those assignments are about. But there's a lot of commonality that hopefully you're starting to notice as you're putting the different things together. Hopefully you're noticing some common things you do over and over and over again every single time. Typos in the script and stuff, I almost don't even count those as bugs. Those will get fixed easy. The big thing is figuring out what needs to happen in order to move the 3 components around the game world. Okay, we have the logical component, and the physical component. We keep coming back to that. So every time we're doing something, we have to think about all the components. They're separate, they're connected, but they're still separate. Kind of like a vector. Internally to the computer, they really are a vector. Vectors of bits, but that's getting a little bit beyond this fast. All 3 of those parts always have to move together and align with each other. We don't want our graphics doing something completely different than what physics is doing. Right? Physics says we're falling, and then we want the graphics to also be falling. And the logical component, the script, we want that to be reacting as if the character was falling. So tying things together is a lot of the thought process, and it makes the problem solving and when putting a game together a little more difficult in some aspects, but easier in other aspects. As compared to, say, business type of software, where it's just all theoretical stuff that we're applying to get some result out of that software. Well, like in the name of the class, simulation. We can, with game development, we can relate it back to a real world situation to help think about what would be happening in the real world. But pretty much for the rest of the semester, all of our stuff, all of our examples, the rest of the content that's going to show up in class is going to come from examples. So I'll open up Godot and start a new example here for today. I need to delete those old ones. There's a bunch of them adding up in. And get Zoom thumbnails out of the way because there's no need to look at that. Project. We'll be walking around a 3D world for the first one. So landscape seems like a good name for it. Again, my copy is probably just going to get deleted, but I'll use Git version control, which I did double check that plugin. You have to download the plugin. When 4.0 came out, they included the plugin. And I guess on 4.1, they removed the plugin and put the plugin on the asset store so they can actually download it. We look at our project folder. This one. We already have the Git files here. So version control is already built into every Godot project as soon as we start it. I'll go ahead and set it up on here. If you haven't used much of version control, a lot of people go on GitHub and basically use it like a drive. They just use it to store, as a place to store stuff. Everybody's encountered that thing before where we have like maybe a final essay for your English class, and you have English final essay, English essay underscore final underscore version 5, all that stuff adds up over time. Everybody encountered that before? That does not have to be done in separate files. We can do all of that in one file. Folders are actually files. Folders are files that contain other files instead of text, but it can all be done in one file. We don't have to do our versions in separate copies of files. That's what version control stuff is. So whenever this starts up, if we go to the asset library, the things download directly. And at some point, we'll look at how we add stuff to that. To get on the ones you can download directly instead of a website, they do have to be free. It's an open source engine. So you can't sell them here directly, but there are 3 official sites dedicated to selling assets. And we'll look at that at some point because that's a good steady source of income. Even if you put them up there for free and ask for donations, or sell them cheap, $1 to $5, lots and lots and lots of people will buy it. So we'll look at that before long, but here, if we just search for Git, right at the top is the Godot Git plugin 4.1. So 4.0 is included in Godot 4.0, but then when they moved to 4.1, they pulled the plugin back out. Just select it, hit download. We haven't seen how to do plugins yet anyway, and then install. And notice that it's installing into the resource folder, so it installs project by project. So every time you have to do a new project, that right here, and now we'll go to project and version control. When we go to version control settings, we'll see this. This is the screen I was expecting to see the other day. And 4.0, it just popped up on its own. So our version control, would be the Git plugin. Need to get rid of the names and stuff. I think we can skip all of this if you have Git on your system. Or have Git on the system. I might not. Okay. That wasn't an error message, so I'll just use the Git that's on my system. I would highly recommend installing Git first. You can just search for download Git. It should go to the latest version. Just download and run the installer for whichever system you're on. To get the latest version, Mac and Linux all come with Git installed already. And Windows does a little. It does Windows that part. It was invented for Linux, for the creation of Linux, and so it's on all Linux systems, and Apple just decided to include it at some point. It's not an acronym. That is the British English Git, which is an unpleasant gentleman. In American English, we kept the one for women, starts with a B, but we dropped the male version. Linus Torvalds always names stuff after himself, so it's not an acronym. I think if we just leave these blank and hit apply, it will automatically do that. And now there's create version control metadata. And hit OK. The thing I was looking for didn't show up. I was looking for another tab to show up over here. Maybe I need to actually create it.
So I guess making an icon on desktop would be a good idea.
What's that?
I'm downloading the Git.
Oh.
Making a desktop, I guess
If you want it. Yeah, that's for.
Do we need like access it?
So Git actually comes with command, it's stuff for command line. So the desktop will give you a GUI, but you'll still need we just need the background part. Over here. Well, that didn't pop up the window, the third tab over here like I was expecting. So I'm gonna go just manually start the file here. So if you go to where the project's located and open your terminal in this location. So on a Windows machine, you can just go to the address bar and type PowerShell or CMD, one or the other. CMD doesn't actually do anything anymore. It was removed, people complaining, so they couldn't integrate. It looks like it doesn't actually do the same thing. If you're on a Mac, like when you have the folder selected, if you hit Option, you'll see breadcrumbs at the bottom of Finder. And then if you right click on the breadcrumbs, you'll get a button that says Open Terminal in this folder. If you just type Git init to initialize something and then a dot, that will set up your Git repository. It will set up all the version control stuff. See, we got this extra little folder here. Actually, I might not be seeing the tabs. I need to restart. Make sure everything's on. Cool. See if this does anything different. If not, I need to check my configuration because apparently my computer laptop at home isn't configured the same way as this one. I thought it was. Still no version control stuff. Sorry, flip the little switch that says connect to VCS. That was weird. When I downloaded it before, it was on there. So you go to project version control and version control settings. There's a little switch here, checkbox, whatever you want to call that. And when you hit that, and then hit apply, then we get another tab over here that's for commits. And this shows the entire history of the project. We'll commit some things along the way and then kind of come back to them. We won't dig very deeply into version control, but most people are more familiar with GitHub and don't necessarily know all of the changes, or deal with the changes and stuff. So for us, we're ready to start doing some actual examples and get into developing some games. So I'm going to make a 3D game here. So I'm going to start with just a 3D scene. This will be the logical part. And I guess first off, we need a place for the character to walk around on. And Blender has some nice tools for that. So I'm going to open up Blender. I think we saw the landscape button, didn't we?
Mm-hmm.
Okay.
Actually, we used it and made
Good quick example, right?
a little thing.
Yeah, so it's going to be similar to that, except I wanted to do nicer controls than that default character script. Like actual yaw, pitch, and roll movement. You go in instead of doing that. And then include unhandled input. That's what I'm using it, I should say. Include like mouse. Turn with the mouse and move up and down, or I think the example I have here, the mouse controls the camera. So spin the camera and then pan up and down for a third person view, while the A and D keys turn the character instead of just shuffling to the left like that default script has. A little bit more natural over the movement. First off, we need a landscape though. So we hit A to select everything and delete all of this because Godot already has a camera. We don't need the camera from here. There's a camera in Blender, which is a nice way to get 2D art going. Because 3D models in some ways are easier to make and they'll handle all the shading and stuff. And then you just take a picture of it, get your 2D version. Mark it there somewhere. Yeah, sometimes it's just easier to make 3D models than 2. So I'm gonna delete all the stuff that was there. Oh yeah, and then the light's a big problem. Because Godot has the lighting. So if we bring in an extra light, then everything's just way too bright. So you always want to make sure you delete all those. Under edit and preferences, go to add-ons, and there's two we want to turn on. The first one's landscape, which we saw that already. And the other one, if you look for sapling, this is an add a tree button. I didn't want to show this because y'all had to, that was one of your assignments, was to make a simple tree. This is a parameterized tree, so it's more for programming. And we can generate forests and things like that really quick. We'll just make one or two and then use Godot to make a bunch of copies of them. But make sure you turn both those plugins on. Under edit. Yes. It's also fun. A tree is a good modeling practice too. So if you're new to 3D modeling, trees make great practice because they're going to be unique, right? Gives you something specific to move towards, but still enough freedom as you grow branches in different ways. Or trying to draw a maple tree versus a pine tree and get really good practice with it that way. Also with modeling, remember the DESN classes. They would just be extra ones here, designed. Uh, the one from South Bend, she said they're all learn anywhere classes. I talked to her last week at the trip. South Bend, out South Bend, Elkhart, they're all learn anywhere classes. And the focus there is on architecture and interior design, which might be a good way for game developers to approach it, because you probably want buildings and landscape the building sitting on, things like that. And the one out of Bloomington is more engineering focused, but modeling. Those would be good things to look into and just study these directly. A few of them. 101, sort of an intro. I think if you can get in one higher than 101, actually, let me just pull it up. Parametric modeling is the one you ultimately want. And that's one that they run twice. Yeah, it's so quick to get a character walking around a 3D world. I'm not even worried about just doing other stuff for a moment. It's almost the default of Godot 4 is to get that going. So if we go look at the course, check all the courses, DESN, over those down. You can probably skip intro. 103 would be CAD fundamentals, probably with Autodesk, AutoCAD, some sort of Autodesk setup, but probably not Maya. But it would be made by Autodesk, so you'd get very familiar with how Autodesk lays buttons out and stuff. So you could jump right in Maya. But that's doing like the vector vertices, vertex by vertex, add in the edges and the faces. Architectural design, that's getting into stuff like Revit. That's awesome software to use. Yeah, there's a CAD software has gotten really, really nice. So the CAD fundamentals, you want that, maybe architecture, and really down here, 220, I think. 220 and 223. Those are actually the same course, and they just run it twice, and then students get different assignments on the way through or get double up the practice. But it's basically the same thing with two names, but you want to go for parametric solid modeling. That's what we do, where we start with just a single shape and use extrusion and keep adding things, expanding it out. But quite a few of them in there. If you look through that list on the catalog, look for the ones where you're actually using CAD software. And parametric modeling, this software development, y'all are programmers, right? Parameters like the functions. So when I go over here and click add a mesh and landscape, and then down in the lower left, we have that menu that's collapsed, but we need to expand that. That's all parameters. I can come back to this. But if I come up here and go over the scripting tab and grab the last command that was ran, oh, it's not there yet. You can see the last command that was ran there is just a function to add a landscape. Right now, the parameter is just refresh equals true. But all of these are parameters that are going to feed into the next function that runs. So we set up our numbers. See if I zoom in on that a little. Milestones, that could be a good one to walk around. Our character might fall and get stuck in those, so maybe lakes. Yeah, I'll use a lake. That'll work. And then we can set things up like The number of subdivisions is how many faces are on that mesh. The size of it down here, offset, so we can shuffle it around to different lakes. Move things around. Adjust the sizes and parameters, just feeding different numbers into a function. And after you get all the parameters you want set, when you click somewhere else, that's where it actually inserts. So now on the scripting tab, that last command that ran, I'll place it over here where we can zoom in. And turn on word is this. So that box where we just changed all that stuff, you can see is just a bunch of parameters in the Python function. Which, since this is software development, might as well show this. Import BPY, that's the Python module that has all Blender Python. And then all of our buttons are just running Python functions. But you could come over here and script them out yourself if you wanted to. We can see all the stuff that we typed in there. If you want to copy and paste that and manually change parameters, that would also get you that same instruction, right? Put that in your text editor, change all this stuff, and then just grab it, copy it, and then right over here is a console where we can paste that in and run it every time. And I did not mean to make two of those. Oops. Sorry, let me do that thing that's happened a few times. Quit Teams in case any confidential information shows up or something like that. So there's a landscape for our character to walk around on, except it's really small. It's a 2 meter by 2 meter plane. We could either scale it up here and then import it to Godot, or we could scale it up in Godot and import it. Problem solving, both of them would work the same way. I like to scale it up in Blender, because then in Godot, when we import it, the scale size will be 111, and it's a lot easier to keep track of all our numbers. So if we scale it up there, right, we go over to Godot and scale it 5 times bigger, our scale size is already up by 5. So when we go to enter our speed, our speed's going to scale up. Or maybe our speed won't scale up properly. So I like to scale everything in the modeling software so that it's just at a scale size of 100% in Godot, which is a nice place to start. Makes it a lot easier to keep track of the numbers.
So like basically you don't know in the actual game software what the heck you're doing to make this the correct size, the correct size from the moment you get it.
Yes, exactly. Otherwise in our game script, we have to worry about all those scale factors. And that gets a little confusing. So I think it's easier to scale up here. So just go ahead and select it, which can be easier in the hierarchy. Maybe rename it while we're here. So I think that's the ground. And then this should be the water. I guess I get to name it, make it easier. And then I'll scale it up by 200. That's 480. 200 by 200 by 200. All 3 dimensions. And then bring your mouse back over to the viewport area and hit Control A to apply those transforms so that that's now our new 100%. Same thing on the other way. So select the object. Under the little orange square icon is our transform. So switch the transform data to scale factor 200 size, and then hit Control A and apply those transforms. So now this 200 by 200 meter, or wait, it was 2 by 2, and we scaled it up by 200, so it's now 400 meters by 400 meters. It's a pretty good size world for our character to walk around in. Big enough for a level or so, right?
By default, it's 1 meter, right?
I think by default it's 2 by 2.
2x2? Okay,
Because it uses the unit square, so 1 meter each direction from the origin. 1 meter on the x-axis and 1 meter on the y-axis. So ultimately, it ends up as a 2x2 square.
2x2 by 200.
Yeah, so then we multiply by a scale factor of 200. Then we can add some colors here. I'll select the ground. Go down to the beach ball looking icon over on the right. One for materials. Always makes me think of a beach ball. Probably supposed to be like a sphere reflecting or something. Create a new material here. I'll go ahead and use I'll just use this one. Oh, everything's collapsed. Usually I can see all these. I'm used to seeing all those things. But we just need a couple things. So again, we talked about this before. Color is not enough. Right? It's not enough just to say the thing is green. It's ground. So what's the metallic properties of it? Is like if there's a recent dewfall, or if we're in a really humid area like near a lake, the plant life is going to be extra waxy and look kind of reflective. So very metallic and specular, but trying to roughen this down. And then go to simple material, or we can just choose those. A couple things, and then with the advanced material, it's really easy to get lost in things. So starting with simple materials can be a good option. Same thing for the water. Select the plane, click a new material, something blue, and uncheck that use nodes. That's for procedure, that's for shading, is what that's for. So by default, it's set to give us the starting point for a shader, which I think we'll probably see shaders for the first time next week. Is the plan. Maybe today, because this does go really, really quick. So something blue, it's water, so it's going to be very metallic, very reflective, virtually nothing on roughness. Actually, the first shader I was going to look at was a water shader, so we have water here, so that might work for that one. That'll work. And then Godot and Blender are fully integrated, so all we have to do is come over here and save it in the project folder, which is this one. And a little organization goes a long way. I keep not doing that in the class examples because we don't have much time, and anything we do in the classroom is going to be really small, but I'll go ahead and make a folder. Rename that blends or something, models, some names so you can tell where it is versus the game object you make out of it. Because the most logical thing to do would be to give them the same name, right? Which makes it confusing when we just look at a list. So put them in folders helps to organize that. This is our landscape. Yeah, let's go ahead and make a tree while we're here. So yeah. Scroll back over on the main menu. Blender's about the only software you have to do that on. So many buttons that just don't fit. If you don't see the file menu, but go to file and new, or the standard control N is a new file. The menu disappeared somewhere.
Yeah, it depends on your window size because my window is more zoomed out. I don't have to scroll.
Yeah, I am zoomed in because my screen needs broadcast. It's not just me doing the normal leaning into the screen doing it. So Once again, Godot has a light, so everything gets twice as bright if we accidentally get it with this. So when we get rid of that, Godot has the we're gonna use the camera in Godot.
For something like in a model that is illuminated, like say you make a lantern or something, you better do a light source in Blender or wait and put one in and just make the object and put the light source attached to it in the animation.
I would use it in the game engine. Because it would work that way if you just kept your light like in the middle of the lantern and shines outward. But all of our game engines are gonna have some, and we do not have any control over this light once it gets to the other engine. Depending on the engine it goes into, some of them it's just always 100%. In Unreal, it's all any light source that's not an Unreal light source, it's just all automatically 100%. And you lose any tint or hue or you lose, it's a white light as bright as it can go. And there's no way to control it. So it's better to use the one in the engine. But that being said, at other times it could give a really nice effect that you're not going to get from the engine, that you're not going to get easily from the engine itself. Mm-hmm. So experiment with it, see what happens. When we bring our character in, I'll leave the light with the character so we can see what it does. At least to start with. So yeah, I just hit A to select all and then delete that. And now under object, or sorry, not object, add. Should talk about the proper one instead of just where my mouse was. Under the add menu, if you come down to curve, you should see a button for sapling tree gen. Get a nice little tree, and again, the box down in the bottom left, it is a parameterized tree. Down at the bottom is the presets. So if you wanted like a small maple tree, you can click that and immediately get a maple tree. You can try these things, click and drag for the branch distribution on them, the number of rings of branches coming out of it. The random seed is the starting point for the seed value that popped in there. And just adjust it till you get the tree. There's lots and lots of settings. So up at the top, there's the basic geometry of the tree. That's the presets, like, well, down at the bottom, there's a handful of presets. We have fine grained controls. There are lots and lots and lots of parameters here. And that's that DESN 220 class, parametric modeling. Working with the parameters to get exactly what we want instead of just dragging our mouse around until we get something close enough. Other branches are growing, pruning. The big two, the basic geometry and the leaves, and y'all can click around on the other ones. If you switch that settings to leaves, there's a little checkbox so we can actually see those. Choose the shape of them, how thick they are. Or we want more leaves than that. So the downward angles and rotation, scale, angle, leaves. So the leaves one, I'm just going to click and drag. And also just type a number in there. But any number entry in Blender, you can click and drag as well. And throw a few more leaves on there. That looks like a tree in springtime. That'll probably be good. And when you're satisfied with it, just like before, click somewhere else in your viewport. And once again, follow this part. I'm going over to the scripting tab, and I can just copy the last command ran on a word wrap, and then you can see it is actually just a Python function for adding a tree. So you might want, since everybody in here a programmer, it's a software development class, you might want to copy that last command over to a text editor and kind of study what it is, what those parameters are, and then you can have a better idea of what's in the GUI. Or you could just add that in a loop to create lots of trees with some adjustments based on the loop to make a forest. Really, really easy to copy that command and always Python, right? For I in range of 1,000, and then change some of those numbers based on I there, and we end up with a forest instead of a single tree. Hopefully that part seems easy for everybody in a 200 level class. It's like halfway through the 200 levels, so it's not the intro to 200 level classes either. 248 is getting up there in the numbers. The highest, well, it goes up to the highest number is 268, except for the certification exams and special topics. So the ones at the end are kind of special cases. They just got shoved at the end. But 248 is getting awful close to that highest SDEV course of 268. So that gives us a tree, except for one thing. Notice over here, an icon looks different. If I very quickly go and add a cube, I'll delete it in a second. A cube, all the stuff we work with has this nice triangle icon, looks like a face. Or right, we have the vertices, edges, and faces. I'm gonna delete that, but here we have an icon for a curve. The leaves are a mesh, but the curve is not a mesh. We need to turn that into a mesh. It's really easy. So select it. If you expand it, probably easiest to select it from the hierarchy. Select the tree, and then under object, the object menu there, come way down to convert, and convert it to a mesh. I'll leave that on the screen for a second so everybody can kind of see where that is. And when we click that, well, we can at least see our icon over here change. So now we have that mesh, which is a bunch of vertices connected by edges, then filled in with faces. Add some color here. A new material, just a simple material, and something brown, which is a psychological thing that you might want to follow depending on the level of realism you want to go with. Everybody in the world knows that bark is gray, right? They'll have all seen trees a few times, right? Bark is gray. But when you draw a picture of it, if you put gray bark on a drawn picture, it looks wrong, right? When we draw, we always make bark brown. Everybody does that. It's somewhere in human nature. So there's a little trade-off. If you're going for complete realism, you want to get that full accurate color, but any other time, it's just those little psychological effects. If we don't make our bark brown, it like looks wrong for some reason.
Like the tree's dead, or
Maybe that's what it is. It looks like the life's gone if we make it gray, unless we do the full photorealism, which Blender can do, and Godot can render. But that takes a very, very long time. That's just a little psychological thing. If you haven't noticed it by this point in your life.
It also kind of, it depends on the tree, because some are have a browner shade than others.
Yeah, different things, but there's a little funny thing. Maple trees definitely aren't brown.
Yeah.
But that was the preset I said. Oh, and then the leaves, we can do the same thing. And that's just gonna be a green, so I'm gonna uncheck this. We're not doing shaders. We're not dynamically changing our color yet. We might even get to that today. Choose some color for the leaves, that'll probably work. That'll work. We can bring this into Godot. Actually, I'm gonna go ahead and do that.
I'm trying to find a freaking brown shade.
I usually click somewhere around the yellow.
I know it's somewhere in the orange. That's about as much as I know.
Yeah, you might have to make it darker first. That might make it easier.
Yeah.
Yeah, but that's getting into the art stuff. That's the one, picking a color, picking the right color can take forever. And that's good graphic artist about picking the right color. That's an intense deal. Oh, yeah, I'm gonna go ahead and save this, and this is gonna cause an error in like 20 minutes. So we'll come back and fix the error then. But again, it's that thing. What was that?
I started to turn around, I heard her sorry giggling as I went to ask her what you said.
Oh. Yeah, this is gonna cause an error in a few minutes, but we will deal with that in a few minutes. Cause it won't always cause an error, but I like to throw the error messages in class, right? When we look at tutorials, we see that finished version, the polished, nice thing that's all set up perfect and the code is all written without bugs or typos or anything. Right? No logical errors, no syntax errors. We know that's not how writing code goes. Which at least once every class, I like to do an unprepared lecture to show you all that it really is like what you're used to. Typos happen every third line, and sometimes the logic doesn't work out. But I generally don't like to do that in class because that would just waste all our time. But I want to do it once so that it is getting prepared ahead of time and practicing the lectures does not give a good representation of what it's like when I'm writing code. And I often worry that that might make some people feel like it's doing, they're falling behind because writing code doesn't go as smoothly as my examples in class. We'll do that at some point. So we got all the blends. Oh, actually,
To be fair, as you've said multiple times, you've been doing this since before. How few of us have been around?
yes, I've been doing this for a while. 3D modeling, yeah, I my first excursion into 3D modeling was right after the first Jurassic Park movie came out. And then I'll have formal training in it.
To be honest, I have no idea even what year that was.
92.
92 when the first was.
What was the first thing you made?
The first game?
No, the first model.
It was like a train thing. There was a tutorial in the software. A tutorial, a train and a killer whale were tutorials in the software. And it went slow on the computer back then. It took
I'd imagine.
it took a long time. Like you do the extrusion and then go do some other stuff and come back and then do the next step. And
So think about what the heck you just told it to do.
yeah, the people that made Jurassic Park probably had computers that went a little quicker.
They probably also had Titanic computers doing all that.
I like to think Titanium.
Well, there's a reason why puppeteering is big in the production, and why a lot of, until recently they just used CGI to clean things up, and it was usually an actual physical object on set.
Yeah, yeah. So there's actually been some people wanting to come back to the puppets and stuff. Because people are getting so tired of the CGI, it all starts to seem the same. It's like there's
also people that are doing the opposite, merging the puppets with the CGI, so that the puppeteers are bringing all their skills to making the CGI work. Basically, just having the CGI operate the exact same way the puppets would have.
Yes, art is always changing.
I have seen that in State. Guy is basically strapped in this whole thing on his arm. He's just basically like dozens of controls on the computer that's telling you exactly how to move every single freaking little frame of that little model.
So that's something different. So, we need to,
Motion capture.
yeah.
That wasn't much gap.
Yeah, that's how they do the basic CGI, but that's a different thing. That's getting a lot. Yeah, we won't get there in this class. Now that we have our model, we can just kind of drag it up and drop it at the child of this world and see what it looks like here. Right now, there's a default preview view here. Right, that sky and the light that's here, those are just put in for preview mode, so we probably want to add our own. Which, just like everyone, we'll select the root node and look for a directional light or just search for light. There are basically three of them. Directional light is like the sunlight, has lots of ambient light surrounding it, and it's just what angle is it coming in at. Omni light is a source and goes outward, so think of like a torch. There's one spot, the spot in the case of a torch where the fire starts, and then just a dome of light surrounding it that fades out quickly. Spotlight is like a spotlight, stage spotlight, a cone of light coming down from a focal point. So a flashlight. Those two you can compare to a torch versus a lantern versus a flashlight. Be good examples of those. And directed to a world, probably just choose some directional light. And it does not matter where we put this. Zoom in on it, push F. You can always highlight the object and push F, and that will center it to the screen, so you can just zoom in and out. It doesn't matter where we put this. The only thing that matters is which direction the light's pointing. So just kind of choose a good direction for sunlight. Someplace where the shadows fall nicely. Okay, and then that sun. Okay. Most people tend to move that way out of the way.
By the way, how did you get the landscape out? Did you just drag it out?
I just went here and drag it up.
Okay.
What was the point to center on objects?
F
After,
for focus.
yeah, thank you.
That is consistent across all our game engines too.
Know about that until this class.
So there's a light, which is gonna have shadows and stuff with it, but, in the background, it's just the default one, so probably also want to add a sky. So add a new node. That's under world environment. Search for world environment. I couldn't think of a good introduction to it. Somebody decided to call it world environment. And that's our blank sky box. So when we put that in there, you can see there's absolutely nothing to it.
When you run the game, it's not always necessarily just a sky.
Yeah. Yeah, because this also has other stuff. If I select it here and then come back over in the inspector panel. If we start going down, you'll notice everything's empty, so obviously we have to fill those in. I'm going to call this guy, just give it a name. So we'll choose a new environment. And once we have a new environment, we click on that. And there are different aspects to it. So there's a background. Just put a color back there. When we do shaders, I'm going to use the sky shade. When we do a sky shader, I have a nice simple shader in the. We'll make clouds rotating around. For now, maybe just a custom color. Do something blue, somewhere in the middle, that's bluish. And notice how, just like the real sky, it affects the color of our other model too. Is the way the light reflects. That doesn't look very sky-like. Something like, there we go. For now, just a simple background color, but one of the first two shaders we're going to look at is a procedurally generated cloud. Bless you. To make a nice sky, but then there's some other stuff on here you might want. You see there's fog. Just turn fog on. Probably not that much fog. Density. Nope, not density. I know it's kind of big. Turn that down. This one. Very, very low adjustments. You see what 0.01 does. So let's add some more zeros in there. 0.05.
Yeah,
Very, very, very small numbers on the density here. 0. Then it's getting really small. We hit that lower limit somewhere there. And just find a little bit of fog so that it's not a crystal clear environment or a lot of fog for something spooky. You raise it up off the ground so that like right down on the ground, we can kind of see under the fog. I guess happens a lot more when it's a really thick fog.
it depends on what the fog is.
Yeah. There's a button for overall all fog. We also have volumetric fog, which that's like a spot. So you'll define a little shape like a cone shape of fog above the lake, or a cube of fog above the lake instead of everywhere. And start to get in and get very, very precise control with volumetric fog. Think of volume like a shape. You'll define what that shape is and then how dense the fog is versus regular fog is just everywhere. Lighter. I mean, you waste a lot of time clicking around again, looking for that perfect color, the perfect amount of fog. That stuff can be very, very time consuming. But there's a world land for our character to walk around. We have a tree though, we could add a forest to it. So I'm gonna come back to the root node and add in, actually before searching for a node, I'm gonna grab that tree and add in one tree. Which it would have put like right at the origin. So find a good spot for the one tree. Maybe over here somewhere. In this tree, we want to have fairly precise positioning on it. Find a good spot, make sure it like sticks into the ground. I think I'm way above the ground here. With 3D, you might have to look at it from a couple different angles. Make sure you're not way above the ground. For something like a tree, we can actually maybe stick it through the ground a little. As long as our tree is not floating. And then, well, I'll fill out everything. I guess there's one tree on there, but one lone tree doesn't really look right. We probably want a lot of trees. So making a landscape, which by the way, this is what the next 2-week home programming assignment will be for weeks 6 and 7, I think, or 7 and 8. Whichever one, yeah. This is what we're doing for the next one. So you'll set up a world like this. It goes really. So the node we're looking for to do that is what's called a multi-mesh instance. You start searching for multi, it should show up. And that's just going to make a lot of copies of mesh, which we have to do some adjustments here. But whenever we had that number, whenever we selected the hierarchy, we'll see a new tab here, says populate surface. And what surface do we want to populate? And if we search right now, click the little dots, it doesn't see any meshes. So before we do that, notice how we can see it on our icon. Those Blender models we brought in, they're showing the generic node 3D icon, just a circle. We need to access the components of that node. So if you right click on it, and 2/3 of the way down the menu is editable children. If you click on that, then we can see the meshes that are part of that. Anything with the maple tree, right click and go to editable children. And we can see 2 meshes that are part of that. And this is the error message I was talking about a moment ago. So now, select that multi-mesh instance, the tab, new tab has 1 button, so we click that. We can choose the surface to populate, like the ground surface. We'll click that. And what are we populating it with? So what is this? What are we going to cover that surface with? Lots of grass, or in our case, lots of trees. So I'm going to select tree. But really, I want the tree and the leaves here, right? That's what we're always talking about. We have to, after we finish modeling them in Blender, we have to combine them into a single mesh. Like when we do animations. It's a little tricky if we try to animate several meshes on one skeleton. So after we get the editing done, we want to join them into a single mesh. We'll come back and do that. This is wide, so yeah, that's good. Random rotation, probably do a little. The tilt is drastic. Like, I don't even put it that far, and that's probably too much for trees. That whole slider, I think, goes 360 degrees. I learned really quickly to just not go very far into the tilt. So we might want our trees change an angle a little bit. Grass would all stick straight up, but trees are hard. They shuffle themselves. They just stand back up straight every day. Scale is we leave that at 0. So that just does some randomization. And then the scale goes down. So we start at 100%, and what's going to be our smallest tree? Let's go down to like maybe 67, 0.67. So our smallest tree will be 2/3 the size of our original. And the amount 128 sounds good. Or we can add a 0 there, 1280. And you can see it fills up with that many trees. Obviously, you're going to start taxing your GPU before long. The multi-mesh instance, yeah, you really want to have a GPU. You really want to be, it can be processed on CPUs, but that's the sort of thing we want to go, definitely want to do on a GPU, those heavy workloads. It's like, here's the tree model. What I put in there, 480. It's like, here's the tree model, make 1,300 of those. That's what's for a GPU, not a CPU. CPU needs to be doing 1,300 unique things. So you can see it quickly populated our thing. Gonna get the leaves, so we'll need to fix that. And then the area in the lake's kind of an issue, right?
Mhm.
So let's go back over to Blender and fix those real quick. The leaves will be easy. So remember, the last item selected is the one you see the menu on. So if we click the trunk and then hold shift and click a leaf somewhere. Oops. It's hard to click the leaves. Hold shift, try to click a leaf. Well, I'll do it over here. If we hit the tree first, and then this multi-selection is control. Hold control and select the leaves. We could join them together, and the leaves was the one we would see. If we go the other way, select the leaves first, hold control and then select the tree. It's a lot easier to do here because it's hard to click on the leaves separate from the drone. And then bring your cursor to the viewport and hit Control J to join. Notice it turned them into one object. Ultimately, in that case, the order wouldn't necessarily matter, but you might wonder, right, if leaves is the name that remains, we might want to rename it afterwards. Again, it's easy to adjust the name, but now we only have a single object, right? We see it's fully expanded here, but there's no other meshes that will pop up. Hit save on that, and when I come back over to Godot, it automatically imports. I think this one here, yeah. Did you see that this one did have two meshes, even the one that has already been put into our game and turned into a Godot object, updated, and now has just a single mesh. Can it repopulate at this point? If I come over to multi-mesh, populate surface, when we choose the thing to populate it with, there's only one mesh now, so select the tree. And I'll keep everything else the same, hit populate. We got our leaves, and hopefully you noticed it changed, so that's one you might want to come through a couple times. Like, well, I don't like that layout. I'm come back, hit that button again. Which my computer's starting to slow down because I think we've talked about this in class. I do use the cheapest laptop from Walmart. I always do that. I always go in Walmart by and ask them for whatever the cheapest laptop is. I figure if it works on my cheapest laptop, then it should work on any laptop anybody in the class has. Because most people don't go with the cheapest. Let me get that back to like 800. My computer's getting slow. So I have the integrated graphics, so not a regular GPU, but better than just a CPU, but I still think I need to get that down. Other one is the things in the lake, and what I like to do with that, well, it's a good example of what we're doing here, right? We're developing a game. Software development is about problem solving. So it's a problem to solve. How do we keep those out of the lake?
At the lake bed.
Exactly. That's sort of the easiest solution. And also, while I'm at it, I'm going to go in File Explorer or Finder if you're on a Mac, or whichever one you use on Linux. I always use Ranger, but that's a nice, whatever way you have, if you double click the Blender file, you can have multiple ones open, which is really, really useful because we're working with both of those models. So kind of doesn't make sense to have them both open at the same time. So what I'm going to do is I'm going to look straight from one of the sides. I'll just click one of the X or Y icons. So we're looking straight at the side. Maybe zoom in a little bit. Pick it out the side. Like looking straight at the side, I can kind of see where that lake edge is. And if we went and started selecting things, right, click and drag, and we have a box select. Well, actually, let's go to edit mode. Select our landscape, not the water, the ground, and switch to edit mode. And we have a box select. So if I click and drag, I'll select just those. But when I start to spin, notice how I only selected the faces I could see. The other ones were blocked. So I'm going to go back to the little spinny widget and click on that Y again. So I'm looking in the same direction. If we switch to wireframe, we can select through things. So if you put it on wireframe, and it might be hard to see on the screen where it's on the Zoom call, but on mine, I can see a thin layer where the water is, even looking straight at the side. I'm going to come a little bit above that because every place at the edge of that river, it banked down into it. So I'm just going to come a little bit above that, but below in between the line that's the ground, the general layer of the ground, and where that water's at, and just do a big box select. Just like all of those. And I don't know who set up this hotkey, but P as in parent or package. If you hit P, you get the separation menu. I don't know who set up that hotkey. I think they were probably just running out of letters. Like, oh, there's a P in separation. You can use that one.
How do you, what button do you press to deselect a specific little bit?
Click somewhere in the blank space. Oh,
No, like if you want to keep what you have highlighted, you clicked on a little bit extra, you just want to grab, unhighlight that a little bit.
Hold control and like that. If you hold control and drag another box,
Okay.
it'll unselect.
There's a little bit of terrain way off that's not actually under the water that's dipping just enough down to grab a couple of vertices. That's what I was wondering.
Okay.
On my specific one, there's basically just a random node like in the middle of the plane. Like
Yeah.
I just wanted to deselect those vertices.
Ultimately, based off years of experience, I would say that it is easier to unselect it and try to reselect again. But if you hold control, it'll do the opposite of selecting it. And when we do that, hit E to separate and then separate by selection. And now over in the hierarchy on the right, you can see we have two different grounds. I'm going to rename this one Mud. That way we can tell them apart. That seems like a good name for the one under the water. And save that. When we give this a save and go back over to Godot, it should update and we should see a third mesh appear in the one, even the one that's already been turned into a Godot object. There we go. So now, multi-mesh. Let's go through and do the populate stuff again, which mine's going really slow. So one down on the ground. I think I still have a bit too many trees. Use the trees, some random rotation for them, different tilt levels, scale them out, and when my thing catches up, I'm going to cut that down to about 500 trees, which I already typed. There it goes. And it populate, and maybe my computer can keep up with this one. Okay. So the cheapest laptops at Walmart are getting better, but we can still tax them pretty quickly. All right, that was perfect on the time I was looking for. We will see much better skies soon. But even with all the talking, without the talking, I can do that in like 5 or 10 minutes. I've done it a couple times so. But it's that quick to get a 3D open world going. And when we get to wrap up for today and get to the lab time, when we start clicking around and doing stuff, or maybe later this evening, since we're still on one of the first days of spring, try doing it from scratch instead of doing a whole bunch and edit them. Like do that and delete that one and then start a new one and do that and try to get really quick at that because just in just a few minutes we have a fairly decent world for a character to walk around. We can come back and we can start working with this while building the art assets, while taking a long time for super nice art assets to replace this stuff with later. And if you want multiple trees, so if you wanted pine trees as well, you would do a second multi-mesh instance. I'll call that maple. We're going to see shaders for a sky and ripples in the water. So those would be the first two shaders we look at. Could do that today. I didn't print out the example, but I have the example ready. So I can just pull it up and
I need to delete the multi-emissions if I do that.
yeah.
I remember we did this in the 101 and just the water shader was enough to make my computer go.
Yeah. Shaders are the dynamic colors. So those materials, we make them dynamic.
My poor laptop did not like that.
Yeah, we'll probably, yeah, I think we should probably wait. So I'm gonna give this a save. And this is our world. So maybe put it in a nice folder to keep it organized. New folder for our scenes or worlds or levels. Godot calls everything a theme. Nodes combine into scenes. So that doesn't necessarily relate to levels. And then scenes can become nodes in other levels. Yeah, I'll go ahead and do that. That's what I was gonna do afterwards. Make a scene that's also a player. And then we'll put it in there. And then we'll put that player scene into our world scene. Or we could have another tab that's like the game tab. And we put both the world scene and the player scene in there. That's right after a break. 10 minutes sound good? I know I'm getting thirsty. My voice is starting to crack. I really use a sip of coffee. Your hot cup of coffee will hopefully help with that, but I might need to grab a cough drop as well. It's allergy season. Any questions about that? Definitely something to play around with. Yes.
Really complicated. So is it possible to turn the multi-mesh where it only places objects depending on the normal?
You'd have to change your model. Change your model to change the normals on your model.
Yeah. Mesh that, or like makes a custom bit of like models to purposes. You base it off of if this for basically can't place any.
Oh, you never heard that yourself. No, because that is not that's something for a CPU, not a GPU.
Or considering.
So think of it that way. That would require processing, which means the GPU can't do it. The GPU can like pick up a big chunk and move that big chunk all at once. But if it has to do any calculation, the GPU can't do it. And that would require calculation and process. You would have to separate your models by the normal basis. The only things at that angle would work.
Probably you'd either have to just.
When you go to separate it in Blender, it's easy. You can select based off the normal and then separate by selection. So then you just have all of those faces in a unique mesh. But you can't do it in the multi-mesh instance.
So basically like what we just did there when we separated the lake bed from the land, you would do there's a different way to select everything at this angle or whatever Blender.
Yeah, I did that, but like manual selection.
Yeah.
Which is why I asked them, because I have manuals.
Yeah, like it wouldn't look right on the canvas. I had that problem as well. It took a minute when I had a character walking through a canyon and there were trails up the side and periodically wanted trees to block it. But it's not problem solving. We should take a break though. We've been at it for over 10 minutes. All right, so my clock says 2:20. We'll get back to it at 2:30. I'll see y'all in just a moment.
But sometimes players like finding random shit in random places because like in Power World, I wound up glitching myself under.
Okay, that's fine. Yeah.
Actually